In the next couple of videos, I'm going to be talking about the topic of ionic bonding. And so for this first video, what I want to talk about is the concept of ions. And I've gone quite a bit into ions in terms of ionization energy in the past videos. But what I want to look at specifically here is the formation of ions, whether it's from anyway, oh, that was distracting. Anyway, sorry about that. So what I want to do in this video is talk about ion formation, whether it's from the removal of electrons or the addition of electrons. So either way. Now, elements usually form ions when they get or atoms or molecules usually get they usually form ions when they get electrons, and they can get these electrons usually from other atoms. So usually when an atom gains an electron, some other atom somewhere lost an electron to give it to that ion. So let's take a look at a couple of examples of where an atom has been ionized. So I'm going to draw out the chemical, actually I'm going to draw out the Bohr model of what it would look like, and also the equation of what is actually happening. So let me select an element. Let's do fluorine. Fluorine is group 7, and fluorine wants a noble gas structure, and it probably wants to get a electronic configuration like neon. So what it wants to do is gain an electron. So I'll draw that up. Fluorine 9. Okay, so fluorine is gonna have the nucleus of fluorine. Let's draw that first. So fluorine is gonna have two shells. So it's gonna have the inner shell, which is gonna have 2 electrons, and it's gonna have the outer shell, which has 7 electrons. So let me just draw that on there. So that's the 2 electron. No, well, hold on. This is the 2 electrons, and this is the 1, 2, 3, 4, 5, 6, 7. So that's 7 electrons, and there's, as you can see, there's a space in this shell for 1 more electron. So fluorine, what fluorine is going to do is fluorine is going to accept an electron, and this electron is going to come from somewhere. But let's not worry about where it came from. But it's going to get an electron, and then it's going to form a fluorine with the electron configuration of neon. So if I now draw this fluorine again, actually I won't draw it again, I'll just okay, so I can copy this, edit, copy, edit, paste. So there we go. Now I've pasted this fluorine thing, the fluorine atom, and so now let's draw in the electron that just came in. So as you can see, now this fluorine has the electron configuration of neon. It's got a full outer shell with a whole 8 electrons, and it's going to have a positive charge. So what we do to represent that positive charge is we draw square brackets usually on it. So I'll draw square brackets also on the first fluorine, which didn't have a charge. So there we go, square brackets. And the fluorine which was produced, I'll draw square brackets on there. And we represent the charge outside of the square brackets towards the top right of it. So we would write, since it's gained an electron, the fluorine has basically been reduced. And reduction is the gain of electrons, and the gain of electrons is it gains a negative charge basically. So it's going to be 1 minus. So this is what the fluorine ion looks like, which is just formed because fluorine wanted the configuration of neon. And so if I draw this as a simplified reaction, what we have is that fluorine plus 1 electron forms F minus basically. So this is basically the process of what has occurred to produce that fluorine. And now let's take a look at one of the reactions which would produce the opposite. So it would produce, let's look at a reaction which would produce a positive ion rather than a negative ion. So I'm going to choose one from the group 1 or 2. Let's choose magnesium, Mg, which has 12 electrons. Magnesium, so I'll draw this down here. Let's get the square brackets done first. Magnesium. Ooh, that's a long G. So magnesium's gonna have a total of 12 electrons. And it's gonna have 2 electrons in its outer shell. So yeah. Let me just draw the electrons up there. So it's got 1 electron here. Those are big electrons relative to magnesium. I'm gonna draw them a little bit smaller. Okay, that's fine. And that's gonna have 8. So 1, 2. And then this is gonna have 2 electrons on its outer shell. And what magnesium wants to do, since this is this requires less energy to do, what it's gonna do, rather than gaining loads of electrons, because if it was to trying to get a full outer shell, it would need to gain a lot of electrons. So what it does instead is it just loses those 2 and gets the electron configuration of let's see, of neon, just like fluorine. So what would happen is that magnesium would gain an electron just like the other one did. So no, I did not just say that. Oh goodness. Yeah, so what magnesium would do is lose an electron, not gain an electron. It would lose the 2 electrons. So it would lose those 2 electrons, and it would form a magnesium ion. And so if I draw this big arrow and draw the magnesium ion here, Mg, and rather than drawing all of the shells, what I'll just do is draw the outer shell. So as you can see, in this outer shell here, there are no more electrons there. Whoa, the outer shell which used to be there, there's no electrons in it. And so the electrons in that shell, this shell being like this shell and this shell, the same thing, there's no more electrons there. And so this is basically magnesium, a magnesium ion now, and it has a charge of 2+ since it lost 2 negative electrons. And so if I draw the equation for this reaction, what we're going to have is that magnesium basically reacts and loses 2 electrons. So it's going to form Mg2+, which is the magnesium ion, and it's going to form the 2 electrons. So those 2 electrons are now free to go and ionize something else. And what happens is ions can bond with other ions if they are oppositely charged. And so I won't go into that in this video. What I want to move on to is another type of ion, and it's a complex ion. Not complex ions, compound ions. Compound ions are basically ions which have more than one atom in their structure. So they have more than one atom in their structure, and together they form an ion. So overall they have a charge. So there's a couple of ions which are quite common in AS chemistry, and I'll basically look at those. So the ions which we come across are the nitrate ion. So you know, nitric acid, nitric acid. We have the nitrate ion, and we have the sulfate ion. sulfate ion. And we have the ammonium ion. And we also have another type of ion which is contains carbon, which is the carbonate ion. Carbonate ion. And I'm going to be making some videos about carbonates with relation to group 2, but yeah. Anyway, so these ions, the nitrate ion has the structure NO3, and it's 1 minus, so it's NO3 minus basically. And the sulfate, if you imagine the actual acid which releases this ion, you can think, okay, the acid that releases sulfate ions are H2SO4. So if we were to remove 2 hydrogen ions, it would probably have a negative 2 charge. So it's going to be SO4, right? Like H2SO4. And then it's going to have the 2 negative charge. So SO4 2 minus. And then we have the ammonium ion. And the ammonium ion is basically an ammonia ion. So NH3. Which has accepted a hydrogen ion, so it's accepted a proton and become NH4 plus. So that's what an ammonium ion is, NH4 plus. And then we have the carbonate ion, and the carbonate ion comes from carbonates, and carbonate ions usually associate themselves with group 2 metals, and it's usually a ratio of 1 group 2 metal and 1 carbonate ion. And so from this I can deduct that it's probably going to have an opposite charge to the charge of group 2 ions. And group 2 ions usually have a 2 plus charge. So carbonate ions probably, 2 minus charge. So carbonate ions have the charge of CO3, and then it's 2 minus. So you can imagine this when it's hydrogen carbonate, it's like H2CO3, or I think that's carbonic acid or something. Anyway, so these are the 4 ions which we commonly come across, and these are called compound ions, and these can form salts usually through ionic bonding, which I'm going to go into in a later video. So I hope this video was helpful, and I'll see you in the next video.